have some notes available to take. So yeah, today we're going to simplify expressions by combining like terms and using the distributive property. And then we're going to solve equations by combining like terms. Actually, I don't think we're going to do that. I don't know why I wrote that one. We're just going to talk about the distributive property and how to combine like terms. Does anybody remember the distributive property? If you kind of remember what the distributive property is, type the number 1 in chat. Right. Oh, I'm getting ahead of myself. This is what's due this week. There are 3 lessons. If you guys signed on yesterday, you probably momentarily panicked because Jen, well, not forgot, but Jen did it wrong in the grade book, switching over from quarter 1 to quarter 2, but it should all be adjusted by now. So you guys should have 4 assignments to do for math. One of them is the live lesson. So yeah, another one's a math mindset. So it's really 2 actual math assignments. So not bad. Not too shabby. Okay, first thing, I just want to review. What are the steps we take to, oh good, I love to hear that. I love it too. It's so black and white. There's concrete steps that you take. I love that. What are the 2 steps we take to solve a 2-step equation? 2 main steps. What do we want to do? So like if we had this equation down here, oh, there it is. What would I do first? So remember we talked about drawing a line down in the equal sign and identifying your variable. Which of those numbers would I get rid of first? The 2, right, the positive 2, very good. So the first step that we would say is we would say get rid of the constants by doing the opposite operation. So that's what that 2 is called. That is the constant. Okay, so once we get rid of the 2, so that's a plus 2. Once we get rid of it, we'll do minus 2. So we're left with 8 and negative 2p. Now we got to get rid of that negative 2. What word is that negative 2 called? Do you guys remember? It's another C word, and it's not cookies. I just want cookies. That's the only reason I said that. So our first step was get rid of the constant by doing the opposite operation. So the operation that was going on was we had addition. So we subtracted that constant from both sides so that our equation balanced. And now we're left with negative 2p equals 8. So we got to get rid of that negative 2. Who remembers what that negative 2 is called? It starts with a C, ends with a T. It's not constant. That's the positive 2. Somewhere in there is the word efficient.
Coefficient.
Hint, hint.
Coefficient.
Rhymes with coefficient. It's a terrible word, I know. It's not even a word. What do you guys think? Coefficient, yeah, very good. Our next step is to get rid of the coefficient by doing the opposite operation. And with two-step equations, what's kind of cool is that for number 2 here, you will always be adding or subtracting. And then sorry, that was number 1. And then for number 2, you'll always be multiplying or dividing. So, yeah. Very, very cool. Okay, so now that -2 is being multiplied by the p, right? Because whenever a number is right next to it, it means multiplication. What's the opposite operation of multiplication? What do you do? What's opposite of multiplication? Division, that's right. So we're going to divide by -2. So we get p equals -4. Very cool. Those are our steps to solving a two-step equation. Yay, we did it. So you got to keep that available. You know, if you know how to do it, don't need to write it down. But if you are a little shaky with your equation solving, definitely make sure you're taking good notes. Sometimes it just helps to have lots of examples. So depends on what works better for you. Any questions on this one? If you have no questions, go ahead and write nope in chat. Ah, kitty. That kitty. So Ayub and Evan are okay. Nadia's okay. Audrey's saving her kitty. Ava's okay. Now, what's tricky is that some of you guys might not have done the two-step equation solving just because of time or whatever last quarter. What I'm actually going to do for next week, I'm going to add a two-step equation solving assignment in there just for practice. So you will see that added in there next week just because you really need to know how to do it. And if you don't know how to do it, please just talk to me. Let me know. Send me a message and we'll work together. This is probably one of the biggest things out of algebra you got to know how to do. We got to know how to do those two steps and then multi-steps. So good. I'm glad. That kitty, I tell ya. That darn cat. What about the rest of you guys? Is anybody still writing? Which is totally fine if you are. Cade, Freya, what do you guys think? Still writing? Okay, Addie's not. Okay, good. All right, if that's you, let me know and I can go back. Otherwise, I will post this video. Okay, so distributive property. What is the distributive property? Does anybody remember? Like if I wrote it out like this here, if I did A times B plus C, what would you get if you used the distributive property there? I think we did, yeah, we did do that here. We did a foldable of this. So it's in that foldable under distributive property, or you could take a whack at it. Remember, if you write on the screen, I can't tell who it is. I said that once and someone was really sassy. They wrote something sassy. Not naughty, just a little sassy. Nobody's ever been like mean at this school, you know, to me at least. So it's awesome about Blue Sky. So what do you guys think? What would we get if you use the distributive property on A times B plus C? Remember, the A, B, and C are like numbers. And remember, the A, like I pretend the A is a person who has a big bag of candy, and B and C are like trick-or-treaters coming to the door. So A is going to share the candy, share the candy. What do you guys think? And we always distribute with multiplication. If you have no clue and you just want me to go through it, let's type number 8. I like the way the number 8 looks. Like a snowman. I sound really weird today. What do you guys think? Unless you're looking at your foldable, which is fine. Can you guys hear me okay? I'm not in radio silence, am I? Ruh-roh. Oh, good. Okay, good. Good. Okay, who remembers distributed property, or if like what you would get up there? If you have no clue, type in number 8. If you are trying to find your foldable so you can look it up, type in number 5. Okay, thank you. See, that's helpful because then I can, get some good feedback. And sometimes it's really annoying to type, I'm looking for my foldable, give me a second. Or, Jen, I truly don't remember, just go through it. Both of which are acceptable. Oh, pardon my yawnage. Whew. Ooh, Addie. Yeah, Addie's got the example down here. That's perfection. Very good. Yes, distributive property, what we do is we take the guy on the outside of the parentheses and we multiply by each term on the inside. So it's like the A is sharing the candy. So for the definition, we would write A times B plus A times C. And that's what Addie did down at the bottom here. So we have 2 on the outside of the parentheses, and 2 is going to share the candy and share the candy. So we would go 2 times 3x plus 2 times 3x, that's the first one, 2 times 7. And then we definitely want to simplify that. So we get 6x plus 14. And that is not an equation, that's an expression, so we really can't solve it because it's not equal to anything. And in the terminology, in the explanation there, it says to simplify an expression. This is simplified because can't do anything else to it. Does that make sense? Anytime you guys see a number in front of parentheses like that, you have to use the distributive property to simplify before you can combine like terms or solve. So this is a very, very, very important first step. And we only distribute the number right in front of the parentheses. If you guys had something like this, what you would distribute, the only thing you would distribute is that 2, that number right in front of the parentheses. So you would distribute, and then afterward you would combine the like terms with the 2. And we'll talk, you'll see an example there. Cool. Make sense? Hello. I put the notes back up there just in case I went too quick. Does that make sense, guys? Okay, cool. Coolness. All right, so we're going to do this example here. We're going to do a few examples. So take a look at this first example. Now, whenever you have a negative in the parentheses, it makes it a little trickier. What I would do is remember that every single subtraction problem can be rewritten as adding the opposite. So 5y minus 10 can be rewritten as 5y plus negative 10. You slide that negative to the second term and put a plus in there. Okay? Otherwise, it's just really hard to keep it straight. So we have negative 3 times 5y minus 10. I see a minus sign in the problem, not the negative 3. Negative 3 is fine. That can stay just like it is. But I'm going to change it to negative 3 times 5y plus negative 10. So we're just sliding over the negative to make it easier to work with. Now I'm going to share the candy, right? Negative 3 has the candy. He's going to share with 5y and then share with negative 10. So we get negative 3 times 5y plus negative 3 times negative 10. And then what do I get when I simplify this further? What do you get? What would our expression be? Because we can multiply here, so we want to do that. We don't want to leave it like this because this is not simplified. What would my final answer be? Yup, 15x. However, see how it's a negative 3 there? We would have negative 15y. Yeah, good catch. Y plus, what's the second part? What do you guys think? This first part simplified to be negative 15y. What would this second part simplify to be? What do you guys think? Negative 3 times negative 10. $30. Yeah, very good. 30. So our final answer would be negative 15y plus 30. And we can't do anything else because it's not equal to anything. There are no like terms there to combine. So we are good. Does that make sense to everybody? I asked this just because, you know, I'm getting some response. It's really good, but I just want to make sure if we are confused. If you are feeling confused, go ahead and either type or write on the slide a question you might have, or like a part that doesn't make sense, or if there's a part in our steps here that doesn't make sense, you could like put an arrow next to it or something. So yeah, okay. Are you ready for the second one? This snow is making me so sleepy today. Of course, my cat is curled up in a chair. She looks so peaceful. What do you guys think? Are we ready for the second example? It looks icky, but it's not bad. Not bad at all. Yeah, me too. Are we still there? Emma, Eva, Priya. Vlad, how we doing? Questions? Going good? If you're good, type G2G for good to go. Nice. Okay, good. Good. Ooh, G3G. Evan's really good to go. Okay. So see this one here? It looks a little crazy. What's crazy about this one? What looks a little more difficult about that one? Not difficult, but like, what is the issue? What are we going to maybe want to fix? The fraction, yeah. Nobody likes fractions, right? Definitely not. That's an icky part. And let's look at where it's written. See how it's written on the side? Ooh, Audrey likes fractions. Yay! Somebody does. That's good. So, but that's okay. Either way, good stuff. Yeah. Oh, Marina. So you're probably just like someone would be put off by a fraction. Yeah. Yeah. Seriously. I was initially. And then look where it's placed. It's placed behind the parentheses. So first thing I would do is I would rewrite it so that 1/2 is right in front of your parentheses there. Oh, and it's a subtraction. What would it change to inside the parentheses like that? Instead of 4x minus 12, what could I say? Just to rewrite it so it's an addition problem instead of subtraction. What would it look like in there? Oh my gosh, in these moments where I pause to wait for an answer, I like hear the silence in my house and it makes me sleepy. Oh, yes, Audrey, that's perfect. 1/2 times 4x plus negative 12. We're just sliding that negative onto the 12. Now we're going to share our candy. We're going to distribute. And remember, it's the same way. Even though it's a fraction, we're still multiplying by 4x and then multiplying by negative 12. So we'll have 1/2 times 4x plus 1/2 times negative 12. And here's the cool thing about multiplying by half. Multiplying by half is exactly the same as dividing by what number? Because right now, this expression says I'm going to take 1/2 of 4x and then 1/2 of negative 12. So what's the same as multiplying by 1/2? Dividing by what number? What you think, mis amigos? Your silence is making me sleepy. What do you guys think? Or we could say, what's half of 4? What's half of 4? Type it in chat, please. What's half of 4? Half of 4? Yeah, 2. Very good. What's half of 3? Oh, it's a tough one. I mean, not really tough, but what's half of 3? Yep, 1.5. Yeah, so every time you're doing that, you're just dividing by 2. So multiplying by a half is exactly the same as dividing by 2. So 4x divided by 2 is going to give me 2x. What's negative 12 divided by 2? Or 12 divided by 2 and then make it a negative. What do you think? 12 divided by 2. We're almost done, guys. The quicker you answer, the quicker this goes. 6. Yeah, and then we want to make it a negative, right? Because we had negative 12 divided by 2, so we're left with negative 6. Cool. Those are some examples. Does that make sense? Friends and neighbors, mis amigos y amigas. Okay. Okay, we're going to do the next one. And let's see if we can get some real good answering and stuff here, because it just goes quicker, guys. And remember, you come to live session, you do have to participate in some way, whether it's in chat or your mic or writing on the screen, any of that good stuff. Okay, so check out this one here. We have negative 9, parentheses, 2x plus 3 plus 4x. What would I do here first? What am I going to do here? And this is our last distributive property example. Then we're going to talk combining like terms, and then we're done. What do you think? What would I do first here? I got to do the distributive property because that's what the heading says. So if I did the distributive property, what number would I kind of zero in on? What am I going to distribute? Who's got the candy? Who has the candy in this one? Oh my gosh, someone has to answer, otherwise I'm going to fall asleep. Aha, Audrey, you rock. Thank you. Negative 9. That's right. That is our number in front of the parentheses. That's the guy who's got the candy. Or the girl. Excuse me, the girl. So negative 9, oops, has the candy. Negative 9 is going to share with 2x. And 3. Does negative 9 share the candy with 4x? What do you guys think? Is negative 9 going to share that candy with 4x? Sí o no? Check out where that 4x is. Is the 4x included in that set of parentheses? Because those parentheses tell us who gets the candy. No, they're not, right? Audrey, thank you so much for answering. Seriously. Goes so much smoother when you guys are answering there. It really, 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 really does. Okay, so 4x is not in the parentheses, so it does not get any candy. Poor 4x. So we're going to multiply. We're going to multiply negative 9 times 2x. So negative 9 times the first one plus negative 9 times the second one. And then that 4x is just kind of added on at the end because it is not in the parentheses, so it does not get any of negative 9's candy. Now we're going to simplify. What would I get if I simplify? Oh my gosh, what did I do there? Okay. What would I get if I simplify this first term here? Negative 9 times 2x. What do you guys think? What's negative 9 times 2x? It's the same as negative 9 times 2. Add an x on. What do you think? Emma, Vlad, Addie, Ava, Nathan, anybody? What's negative 9 times 2? Negative 18. Yeah, very good. So we have negative 18x plus, now we're going to go negative 9 times 3. What's negative 9 times 3? Negative 27. Beautiful. And then that 4x is still at the end. Am I done? Am I done with this one, guys? All done? Now we can go home, go to sleep? No, you are right. Why am I not done? Aside from the fact that I said it like that. We have to add the x's together. Yeah, those x's are like terms. So we're going to combine 18x and 4x. What do I get when I do that? That's like saying I owe you 18 x's and I have 4 x's to give you. Negative 14x. Good job. Now we are done. Beautiful. You did it. Woohoo. All right, questions there. So it's just taking the number in front and then multiplying it throughout the parentheses. Yay, math! We got one more thing to talk about. And it's super painful. I mean, painless. Hey, math. Go, math. Okay, let's see. Okay, like terms. We're talking about like terms. In this example here, we have 3 snowflakes, 4 cups of hot chocolate, or hot cider, if you will, and then 2 snowflakes. What are the like terms? What could I add together here? The snowflakes. Yeah, very good. So this is a like term, and it is with this like term. Does the poor hot chocolate have any like terms it gets combined with here? What do you guys think? Can I combine that hot chocolate with anything? No, there's no more. No more. Yep, you're right. So there's no more. So we would combine it. So you see what they did here? They moved the snowflakes in between the snowflakes and hot chocolate. They moved it so it was a little closer. You don't need to do that all the time. And then they added the snowflakes together. 3 snowflakes plus 2 snowflakes is 5 snowflakes. And then we still have those cups of hot chocolate. Okay, so these are some of the words that you need to kind of be really familiar with. A term is a number or product of numbers separated by a plus or a minus. An example here is that 2x plus 7. There are 2 terms there. What are the terms in that first example? It's a number or product of numbers separated by a plus or a minus. So in that first example, what is one of the terms? I'll give you a helpful little underline. Boop, boop. What is one of the terms there? And there are 2. What do you think? Okay, I'll give you one term. One term is that 7. What's the other term? What you think, friends? 2x, yeah, very good. This is the other term. So there's 2 terms in there. The coefficient is the number in front of the variable. So in this example here, it's the 4, just the 4. And it's always connected to that variable by multiplication. A constant is a number with no variable. So in this case, that would be the negative 10. That's a constant. What do you guys think the coefficient of a plane x is? What number is always in front of x, even if you don't see it, if you just have a single solitary x there? What do you guys think? If our term here is just 1x, I give you a hint there, 1x, what is the coefficient? How many x's are there? That's the example. Yeah, what do you guys think? What number's in front of that x, even if I don't see it? It's a very skinny number. Starts with O. Rhymes with none. What do you guys think? 1. Yeah, very good. Very good. Very good. I'm being a pain in the butt, sorry. So 1 is always in front of x, even if you don't see it. Guys, make sure you write that down. If you did not know that, you will want to know that. Coefficient of x is 1. Every single variable that's by itself always has a 1 in front of it, even if you can't see it. Cool. Cool. 1 is the leader. 1 ring to rule them all. I'm sorry, I had to do it. Oh, that's okay. That's okay. We're almost done. I know, I'm super tired and my brain is focused as well. We're almost done. I think this is the last. Yep, this is the last slide. So last slide, just hold on for 2 examples. Okay? I appreciate your honesty. Okay, guys, so how can we want to combine all the like terms here. So what I like to do, every time there's a subtraction part in there, I like to change that to addition. And then every time there's a single variable, I like to add in the variable or the coefficient. So we first have x. What number should I put in front of that x that's really there even if we don't see it? Audrey just said it. 1. I'm going to put a 1 in front of that x just because it really helps when you're combining like terms. Now here's where my minus is. Instead of minus, I'm going to put plus negative, and it's just a 1y, so I'm going to put a 1 there. Now, what are my like terms that I could combine here? What could go together? What has matching variables? What do you guys think? And remember, when we do this, we combine numbers with other numbers, y's with other y's, and x's with other x's. So what are the 2 x's that I would combine here? What do you guys think? Do you guys see this? I'll give you the first one. I'm with the whole fuzzy brain thing today. Oof. So you guys see this 1x and this 6x? Both of those have x's, so I can combine them. 1 plus 6 gives me 7x. What about the y's? What y's am I going to combine? Or what would you get after you combine the y's? You'd think 3y, you totally would, but we have a negative there now. Yeah, that's what's tricky. We change that minus sign to plus a negative. So we have 2y and minus 1y. One y, very good. And it would be a positive because 2y is positive. 1y plus 7x, that's right. And I wrote it as 7x plus 1y, but that's right too. Beautiful. Last example. We got this, guys. Okay, so let us rewrite this so that every variable that's by itself has a number in front, and every subtraction sign is changed to adding a negative. So we're left with 9 plus negative 3z. So we change that minus to plus a negative, plus 8z plus 2 plus 1z. Okay. What can I combine here? Look at all these z's. Guys, see them? We have a negative 3z, an 8z, and a 1z. A 1z, guys get it. So what do I get when I combine all three of those z's? Negative 3 plus 8 plus 1. What's negative 3 plus 8 plus 1? Last example. Yeah, I think you're right there. Let's see. So we have 8 minus, yep, 6z. Good job. And now let's combine the numbers. We have 9 plus 2. What's 9 plus 2? 11. And that is my final answer. 6z plus 11 or 11 plus 6z. Perfect. Does anybody have questions? Sorry if I made your brain fuzzy today. I know mine's pretty fuzzy. It's 12:25. Woohoo! We're not over. Yeah. So that is all I have for you lovely people today. Yeah, me too. Me too.